My name is Andre Roos. I'm from the Garden Linux team. I work here in Munich for SAP, and I'm also the chair for the Garden Linux in the NeoNephos Foundation. Yeah, I'm have the position of a chief architect. You can reach me on LinkedIn here. I think I upload somewhere the slide deck so that you find me whenever you need to. Of course, I don't need to discuss here what NeoNephos is because it's the community meeting. So therefore, we try really to all contribute to NeoNephos. And as we do, we have a lot of projects in NeoNephos. And as you can see, there's a list. Probably it's not the most up-to-date list of projects that are worked on in NeoNephos. And today we talk about Garden Linux. That's the project where I'm in. And it's a Linux derivate that really tries to provide a super minimal Linux image. We will talk about the details in the next slides. And this is also already used by Gardener. That's why we have the name Garden Linux. Because we are providing the operating system foundation for Gardener. Also, it's used in the Iron Core project because the Iron Core project provides an infrastructure as a service layer using also Garden Linux, and Cobalt Core is also a solution from SAP side using Garden Linux. Probably some other people are using it as well, but I'm not aware of this because Garden Linux does not phone home. So, and therefore, yeah, what is Garden Linux? Garden Linux is a purpose-built OS. That means it's super lean, it's hardened, and it's based on Debian. Why? Debian is an open source operating system, but it's missing some enterprise genes. We will talk about this a little bit later. We support here the latest LTS kernel. As we talk, there's currently the 6.18 kernel out, and this is already in Garden Linux in. So therefore, Garden Linux supports this already. We also still support older versions. So the LTS kernel before was the 6.12. That's also available in one of our stable versions. We support all the software that you need to run cloud native workloads. So mainly, for example, Containerd or Systemd. And we provide all this also in super reduced container base images. They are comparable to other base images, but also comparable to distroless images. Distroless images are images that are super small. So, for example, distroless for static C libraries will only have the static C library in, but distroless has one disadvantage. It's not up to date all the time because it's, as far as I know, built by some Google engineers, which only switch to distroless when there's a new stable release of Debian, which is roughly there every 1.5 years. So therefore, the distroless stuff is a little bit outdated, and for that, Garden Linux also provides container-based images. We try to add some enterprise capabilities. So since we are coming from SAP, there's high demand for secure boot, immutability, reproducibility. In-place updates means that we can update as much as possible on a Kubernetes node before we need to throw it away, or as in Gardener terms, to roll it. And we also provide critical patches, including patches from the non-disclosure list. And we are providing this in the speed as we need from our company here, because we have here some requirements to provide CVEs with a certain level and certain dates, but I will have this on the slide deck. We also support various security modules. It's very important. AppArmor is very famous here in Europe. So therefore, most of the installations use AppArmor. On the US side or Northern American side, you have SE Linux, so that we also support. And we lately talked a lot with the SUSE guys, with the Systemd guys. And the Systemd guys are switching currently to Landlock. So some of this is already done on our side. As I said, adding enterprise genes to the whole setup means also that we are post-quantum cryptography ready. So that means we are running at the moment OpenSSL 3.5. And we have to prove in various audits that we are able to switch to this, or that we can provide in a certain speed some cryptography fixes. Yeah, and we provide for all our stuff specialized tooling, but specialized tooling sounds normally very proprietary, but here everything is open. So that means when you go to our GitHub page, GitHub github.com/gardenlinux, then you find everything there. So even if you would go, for example, to Debian, which is very well known for open source, you would not find how Debian signs their kernel modules, because the signing is a process that's somewhere documented deep in Debian, but not public. On our side, it's everything there. You have all monitoring tools, all build tools, all container tools. Everything is built in containers, so you can even reuse our tooling at certain points. For example, when you want to build your own binaries for the kernel, that's all pre-baked. So we have some industry people requesting, for example, adding their own file systems or whatnot, and we can directly provide them our container image, and they can build with our container, not even installing some C compiler or whatnot. It's all prepared. Everything is prepared for various cloud providers, and of course some on-premise stacks like OpenStack, like VMware, all there. We will talk about this in detail. Yeah, what is Garden Linux? Garden Linux is built with three main goals. It should be fully open source. You should be able to reproduce everything. It should be ease of use, and it's of course purpose optimized. So we heard here, SUSE is also part of NeoNephos. So we are not here a competition. We are more or less a super small container operating system that makes sure that Gardener and all the other environments can run very small and out of the box very with all the enterprise features activated. It's not a general purpose operating system. It's not targeting all use cases, so you will not have a Garden Linux with a graphical user interface, and you will also probably not have a Garden Linux running, I don't know, your MATLAB or something that's not supported or that's not even tested here. It runs, for example, a container runtime, so containerd. We really work close together with the Gardener guys and with the Kubernetes community that we have the latest stuff there. So containerd with, I don't know, C group v2 and whatnot. So we already prepared containerd release 2.2, which means some changes in their config files. That's all contributed by Garden Linux to the community and also synced with our sister project Gardener so that they directly can use it. We also provide container base images so that we provide the whole stack. So it's really on the stack for the guys who are using NeoNephos. So that means you can really run everything from an infrastructure as a service provider down to an operating system, up to an Kubernetes environment like Gardener. That's all there, and that's all supported by us. We also support in this area virtualization hosts, which are not meant that you're running your virtualization provider with it, but they are meant that you are able to split your, I don't know, your big bare metal machines into smaller pieces, that they are much better digestible in a Kubernetes environment. As I said, I work for SAP, so we are known for in-memory databases, and our machines are super big. So therefore, we need a lot of slicing down the machines into more handy parts. A current cloud native stack would look like that you have a bare metal machine or something, or a private cloud or a public cloud provider on the bottom, and you have probably a hypervisor on top. And then you have another machine with a container runtime. I mean, this part with a hypervisor can be skipped. And you also have on top then some applications, maybe with a container base image. It doesn't need to be Garden Linux, but it can be Garden Linux. And on top, you have then the other application runtime environments and frameworks. I mean, we have a lot here in the NeoNephos Foundation as well. I don't know, service mesh and whatnot presentations we haven't seen in the last community meetings. I'm not referring to all of them because they are just working on top of Gardener, and so therefore they don't know probably that they're using Garden Linux. Garden Linux is part of the Apero project. The Apero project is a project that tries to provide a reference architecture for high performance in cloud edge infrastructure, and it's funded by the European Union. And one of the very important rules there is that all tools have to be open source and that they have to be available. That's why we provide also Garden Linux into the NeoNephos Foundation. So Apero is, so to say, a sister project here. And we have a lot of infrastructure in from Apero in NeoNephos. So, for example, just to give you an idea, so you have unordered infrastructure. So that means you have servers, you have switches, you have whatnot you recognize in your data center. There's something mounted in your racks. There might be storage. There might be servers as set switches, maybe some smart NICs in those servers. All that you will recognize and you need to maintain. Therefore, you have the Iron Core project. Iron Core provides you a bare metal or infrastructure as a service provider that brings some order in your machines. Of course, if you're using your machines on AWS, AWS is your infrastructure as a service provider, or Google or whatnot. But all those machines, of course, need to have an operating system because you can run something on it. And that's Garden Linux. Here, in that case, fully integrated with the Gardener environment. And if you then spin up your Gardener clusters or your Gardener nodes on Garden Linux, or better on the whole Iron Core Garden Linux what stack, you will finally get some Kubernetes clusters, or better with the name or with the wording from Gardener, you will get something to run your pods. Or to run your pods in Gardener shoots. And that's the whole proposal, that everything is integrated, and the whole stack is also available in the NeoNephos Foundation. I think that, or I hope that explains a little bit what all those projects do. I saw that somebody was writing something in the chat, but I cannot really read it because I have no second screen. So if somebody has a question, please feel free to interrupt me. Good. Garden Linux is building the whole environment, like said, completely open source. What means completely open source? Everything that we do on every image that we build directly at the moment on GitHub infrastructure. I know there are some discussions in the press if GitHub or maybe some other version control system, but that's not really important at the moment. We are using everything on GitHub here, and we are providing a possibility to maintain your operating system with something like a Meta package manager. So that means we are not really using packages directly, but we're using something like features. A feature is where you can say, hey, I want to have an operating system that runs on AWS. Then AWS is a feature, and AWS provides you some requirements. So you have to provide, for example, a cloud-ready kernel that supports all the cloud specific or all the AWS specific ingredients like virt.io and what you have there, the network cards, the storage adapters, what AWS provides. And you also have to run, for example, Cloud Init. Cloud Init will get all the information from the cloud provider, from its metadata service, and configure your machine. And exactly this feature you can enable in Garden Linux. You can combine features. We will have a slide on this in a sec. And out of those features, you can create something that's then called a flavor. So, for example, I have here an example on the screen, lowest line here. You want to create an image that is a KVM image enabled for Gardener. So Gardener is also a feature, and you want to have it production ready. So that means it has everything hardened, everything is available. You can directly work with it. Then you can specify a flavor that's called KVM Gardener Production. And this flavor can also be super specified. So you can say on which platform it runs, ARM, x86, whatever you want. You can even specify what version you want to build, because Garden Linux has the possibility to rerun builds and reproduce builds which are really binary compatible. So if I would build a Garden Linux from, I don't know, a year ago, I would have exactly the same checksum, and that you can use here in this tooling. The last element is also referencing, for example, the Git hash. where we are building against so that you know exactly where it's coming from, and for your reproducibility, you know what you're doing. Everything that we build is built in containers. So as I said, for example, you want to build your Garden Linux, and the Garden Linux checks if you have keys for building your Garden Linux, or better, for signing your Garden Linux kernel, for signing your bootloader and whatnot. And it will figure out you have probably no keys because you just checked out Garden Linux. Then the whole setup will figure out, okay, there are no keys and I can find also no private key for it. Let me generate one. So then the container for just building the keys will generate you keys, will store those keys proper on your system, or if you want to have them stored somewhere else, you can provide some different key targets, but that's not important for the moment here. But it will provide you keys. And while building, it will figure out, oh, that key is not a Garden Linux key. It will tell you that this key is not compatible to the Garden Linux keys, but it's honoring your keys. So if you're running your own build system and if you want to build your own, I don't know, SAP image with an SAP key, you don't have to use the Garden Linux keys. You can use your own key. And of course, it's your task to take care of your keys. But the whole system will be completely signed. It will be completely clean in itself, that you can use this with signed builds, with signed bootloaders, with signed kernel objects. Everything is built in containers. So our kernels are built in containers. The build environment for the kernels are stored in containers that you can check out. Every package is built in a container. Our repo is built in a container. You can check this out, and you can build all the stuff also on your machine locally. We use therefore Podman, and Podman runs as a non-root user, so you can build Garden Linux on anything that you have around. So therefore, an x86 laptop, you can build Garden Linux on your laptop easily, or you can build it on your macOS laptop or machine. You even can use Windows. I think probably our Windows edition needs a little bit more love, so I'm not sure if it really builds at the moment because we have no developer or no request to maintain this actively. And very important, all the boot process does not need boot permissions. So everything that comes out is just there. Of course, there is a lot of fancy stuff I could provide or I could show, but I try to show here just one boot process. Normally, or one build process. Normally, I say Garden Linux should be that easy to build that even my grandma can do it. So therefore, let's try if I can achieve this and tell you or show you how this works. So, and therefore, that would be a build host where Garden Linux is integrated. And everything that I explained to you is very easy. So Garden Linux is just checked out. So if you check here, that's a Garden Linux. As you check it out directly from the repo in the internet, I just did it myself just beforehand to show you here how it works. It's really the up-to-date version. I changed something on one file. I changed git status. Oh, I changed actually some more files. Yeah, yeah, but that was accidentally. I changed something that the ignition process when we start the machine does not take so much time. That was an easy one, turning off ignition because it would otherwise try to contact an ignition server. Just that we can show off here a little bit better how the whole system performs. But it's a live checkout. And if you really want to run a build, like said, it's super easy. You can say build kvm, for example, _dev. You will see in a second why we need a dev version. And then the whole system builds. Okay, I've thrown you more or less in the cold water, and we let this build in the background. It takes something like 5 minutes to build. We can review this in a second, but I will explain you a little bit more of what we are doing at the moment, so that you understand what I am explaining here. So stop this sharing and share again my slide deck. Like I said, if somebody has questions, feel free to interrupt me. I saw some more chats.
Yeah, I have a question related to small distros like Talos Linux, for example, which is very
Yes.
popular in Germany and Europe. How do you see the difference between this, Garden Linux and Talos, because in Talos they don't have SSH. It's all supposed to
Exactly
work as a REST API server. How to find the differences. How to choose actually between these two models. I'm not speaking specifically about Talos, but there's a couple of distros similar to that, right? Lightweight and
yes.
designed for Kubernetes.
You have this also from all the other cloud providers like Bottle Rocket from AWS or I don't know, Google, if they are publishing their stuff. I don't know, but we really try to make this as a complete open source process. So if you take a look at Talos, it's a US company that runs this, and some of the stuff is not open. So that means you can see the code that they are executing, but their build process is not open, and you are depending here on a US company. So I mean, part of the Apero project is that the European Union gets fully sovereign. So therefore, this project here is completely open. We have nothing hidden. I mean, we have stored our keys away, of course. We are not registering our private keys, but everything else is usable and directly available. And features like Talos or like making it super small. I mean, you asked this question without any handshake before here. So you can see here, for example, that our feature system has stuff, and yes, sadly, we really have an SSH feature that you can disable and that you cannot use. So on the Gardener side, for example, we enable the SSH feature, but the SSH feature, like said, it's a meta package manager, will directly configure the SSH not to boot. Why is it then helpful? Because Gardener has a node agent that can go on the node and say, hey, we have an emergency here, turn on SSH. So SSH would be installed, SSH would be available. SSH could be a container, but in the Gardener case, they insist not to have a container. But in some other environments, we provide this as a container, like Talos does. So, and therefore, you could directly combine this with SSH or without. Same here, yeah. So therefore, it's a lot more flexible. And Talos has the other problem that Talos is also not POSIX conform. So everything they do is like in a busybox container. So if you have stuff that you need to execute, for example, a gardener needs to execute some startup scripts, which will not work on Talos directly out of the box.
Okay, thanks.
Good. And therefore, coming a little bit more to this features and flavors setup, I mean, you saw me starting some feature. I said I want to build a KVM here, yeah, and I said I want to have a dev feature. So you can combine this as much as you want. So there are features like you want to build a server, which is more bare metal. You can say you want to build it for the cloud, so the kernels are super reduced. You have no, I don't know, Turtle Beach sound card support anymore. Which is probably not needed in the cloud, but maybe on your bare metal machine. I don't know what you are doing. So, and therefore, this is all in there. You can have a container host, you can have a virtual host, you can have a Gardener host. You can run this for various platforms that are all features, and the combination out of those features. I mean, we just started to build a combination out of these features. It's KVM dev. That would be a flavor in the Garden Linux speaking. And so therefore you're free to combine whatever you want, and you are able really to remove also SSH. So Garden Linux has not necessarily SSH, but for example, some of our installations or most of the installations will have SSH because Gardener requires this for debugging. It's not our fault. Good. Yeah, some technical details. It's easy to build, like I said, even my grandma should be able. So you saw just one command. I just checked it out. I didn't cheat it on anything. I didn't prepare anything. It's not 100% true because I run one build before, and this one build already built my keys and already downloaded some stuff. But that was the only cheat, so that our build is fast enough. And I don't know, as we speak, it's probably already finished. Everything is repeatable. So we have even some CI pipeline checks in there if we build repeatable. So if somebody would check in something that breaks this, we would directly see it in our GitHub production. They are auditable. So that means you can see this in people rebuilding stuff and saying, hey, on our machine, it doesn't build. And you can really see what happened and what was installed. Super small footprint. So currently this Garden Linux, what what we presented here is a Gardener-based Garden Linux. So that means it has already some Kubernetes on there, some containerd, and it has 600 megabytes. Sounds a lot, but if you see all this Kubernetes stuff that has more than 350 megabytes only for Kubernetes stuff, then it's not a lot. Okay, then you see here it's all completely systemd based. So some guys that know probably Debian, they know that they are not completely systemd based. So they have still something like if up, if down. We don't have something like this. So all this is really the newest technology here. Also, the init RAM is generated with Dracut, so all fully integrated with systemd. We are running the latest LTS kernel. It's all MIT licensed, so you can freely use this. We can produce immutable images if you want. If you don't, then you select the proper feature. We are at the level of OpenSSL 3.5. Of course, you can use older versions, and also the 3.6 is available, but not selected for stable releases for some other reasons. And we have unit tests, platform tests if we violate some licenses or if we have outdated server software in our stack. So all this is automatically done. And since we are not a super big team, all this is completely automated. And we are supporting all the cloud providers. You saw it in my little bubble here. All this like AWS, Azure, GCP, AD Cloud, VMware, OpenStack, KVM, that's all supported. I said before we are adding some enterprise genes. So we have a security tracker. Debian also has a security tracker, but the Debian security tracker is only for their 3 suites available. We have a security tracker that's for all our versions available. We provide CVE fixes with a score 9 or bigger. Yeah, the sign was not easy to write. So equals 9 or bigger in less than 15 days. We provide CVEs 7 or bigger within 30 days because there are some enterprise requirements that are on our side here. We provide nightly builds. Nightly builds don't differ from stable builds, only that they are not maintained anymore. So therefore, you can get every night a build. That's not really true. Over Christmas, something broke. So the demo gods were not good with me. So if I want to show you the last nightly that was building, I think it was yesterday and then before Christmas. But that happens. It's normal development. And yeah, so therefore that's all available. We have stable releases, 1 release per year or maybe 2, depends on security situations and software update setups. We maintain at least 2 versions depending on other factors, what is needed, needed for stabilization, but we commit for 2 versions. It's comparable to the Kubernetes life cycle. Yeah, then we try to get our product certified. And now here's a star on there. It's not EU funded because certification cannot be funded by NeoNephos or by EU money from the Apero project. So therefore, we provide the certifications over SAP's infrastructure. So for example, if you want to have the project or if we want to have the project certified for CIS or whatnot benchmarks. We do this on our side and on our own behalf, but all the features go back to the open source product. So you can directly use this. Of course, if you want to have a FIPS certificate from somewhere, we need to talk because I think that's not so easy to share, but that's a different story. And yeah, Garden Linux runs everywhere because we are nerds. Yeah, we really tried to run this on servers, of course, x86 ARM. We have this running on switches, so you can see switches like the Sonic switches can be also operated with Garden Linux. We have some SmartNICs, Mellanox SmartNICs, or some Intel SmartNICs that have been running already with Garden Linux. It's very important because you need this for your compliance rules. And we even run on GPU hosts. Yeah? So for example, you see here the German AI super factory that's built in Munich. Hopefully we get it all done with Garden Linux. It's not our fault if not. But if all the legislative stuff from NVIDIA works out, we might be even running on there. AI hardware support is not directly supported by the EU because it's an American company. So therefore, we provide this on our own, but we also share all this. But for example, there are some problems with licenses. So NVIDIA binaries are allowed by a license holder, which we are, to be provided in binary format. But if you would copy or if you would fork Garden Linux and you would build your stuff, you have the problem that you are probably not able to provide the binary files that you just build it. In your company, no problem, but I'm not here your license advisor, so therefore check what's possible. But that's pretty cool that we really have all these features available and that enterprises can use the full set of features of Garden Linux by being fully open source. Garden Linux adoption, I know that it's running in SCP because that's my job. It runs there with several 100,000 installations. It's running on Stackit. I know they are using Gardener and they are using Garden Linux. I know that there's a significant amount of installations on T systems. They are using Garden Linux also with at least 5 figures. I know that 23 Technologies is using Garden Linux. Some of our partners, they are also contributing to Garden Linux. It's 23 Technologies, also Clyso. They are running even their storage machines on it. And Cyberus Technologies really tries to get some of our stuff also from the German BSI certified. So therefore, that's what we know where we run. I also had some calls from some insurances here in Germany. They're asking questions, but I don't know if they are running Garden Linux or just ask questions because Garden Linux is not phoning home. So, and yeah, and therefore we are more or less at the end of my presentation and hopefully, because I could not sneak, my build was running through. So let's share the screen directly. No second possibility here to cheat. That was the screen we were starting. So, and the screen was running through. You see all the builds. You see, yeah, those errors, they are documented. There are some that's not really an error. That's just something that tells you that this shared library is not there because it's built during this process. That's all normal, but you can see really what's happening. You have a build process, you have a test process. All this is locked since I have not enough time here to present everything. But if you look at our GitHub account, you can see in running actions, it's public, what has been done, what has been tested, what has been platform tested. All this is seeable. And this build process, yeah, I think it ran in less than 5 minutes and I was talking just too much. Sorry for this. But for example, this Garden Linux here is really built. So therefore, let's check, let's prove, at least on a timestamp, we have a builds folder. And in this builds folder, you can see, maybe I should order it by time. So, and then you can see that we built here this file 1638. So you can now verify if my 5 minutes was right. So I'm obviously talking a lot. Sorry for that. So, and therefore you can see that this was built at that time. It has 2 gigs, but that's not true. Those 2 gigs it has are 2 gigs because of inflating of the operating system, because that is a requirement for some uploads to Azure, and therefore it's artificially blown up to 2 gigabytes. If you take a look at the real byte size, oh sorry, mistyping stuff, and you can see it's really using 642 megabytes, and like I said, there are 330 megabytes only Kubernetes stuff. And of course, we provide a little command line tool, but that's not our core business. To start this, you can really test to start a VM with this. And that's how I want to conclude my presentation. So you can see how the VM is started, what is in there. So, and it's booting a Garden Linux. Since it's outputting so much, the ASCII transfer takes a lot of time. If you would switch that off, the boot would be done in 3 seconds. So it's done in 13 seconds because of the ASCII output. You can see a Garden Linux, it's built, it's running on 2 CPUs. And now you say, oh, wait, this guy said something about security and now he's logged in without any user. Yeah, the interesting part is Garden Linux has no user. So you can see in the code there is no example user, there's no default password or no default user because it's all integrated in those cloud providers. So if you say now I will want to build it for AWS, you can go into your AWS console and say I want to have an admin user. Or you can go even to your OpenStack console and say I want to have an admin user and then it's added. So therefore, how do you boot that or how do you log in? Yeah, if you don't have a cloud provider, you don't. So, and for that reason, we have a dev build, and the dev build just disables the check for users. So therefore, it automatically logs you in as root. You can see how it's done. It's a two-liner in code, and you can disable this on a dev build, but you can use it actually. And it's a Garden Linux that runs here, up and running. I don't know if someone is interested in some output. So if you want to see what's running here, it's almost nothing running, the whole systemd farm. Some SSH guard because I'm going in via SSH here on some stuff of this. And yeah, so therefore SSH could be disabled, Piotr, if you ask this, but then it's difficult to show this. So therefore I really need a serial command line. That's also possible, but that was too vague for me here to spoil my demo. So therefore, yeah, that's more or less the conclusion. If you have some questions to this command line, feel free. Otherwise, I switch back to the presentation mode. No questions.
So maybe one question.
Yeah, feel free.
Since everyone is excited about AI today, are you planning to support any kind of AI-driven terminals for this Linux? Did you think of it?
That's in fact no problem. Yeah, if you want to add this feature, that is probably it's already available in Debian. I never played with something like this, but we can add this at no pain. Yeah. So therefore,
I noticed that people who started to use terminals supported with AI, they don't want to go back, right? Since we start using it this way, it's like one way path.
you might be right. Yeah, that's well, maybe it's your first contribution.
Yeah, we'll see.
Okay. Like said, I mean, I could go on and explain you something about the trust domains. I think I'm already over time or almost on top of the hour. We have 9 minutes left. So therefore, let's conclude. And if you have more questions, feel free. We are part of the NeoNephos. You can find us under gardenlinux.org. I have put this here in some QR codes. So if you really want to step in, and Piotr, if you want to provide an AI-based terminal, feel free. That should be, if you know what you are doing, it's probably 10 minutes work. Anything from anyone?
I'm not sure about security.
Yeah, that's a different story. Yeah.
So thank you very much for that presentation.